People, hope we're doing well. Let's go ahead and jump back in on this one. We're going to do another problem with repeated factors in the denominator. This time we have two of them, okay? And so what happens here is we need to, what we did with the repeated factor in the last problem, we need to do with both here. So what we're going to have is we're going to have a over x squared, b over x, c over x minus 1 squared, and d over x minus 1. Now, again, we only have two convenient values. Well, first of all, let's go ahead and get it into more of a polynomial form. Okay, a is going to have x minus 1 squared. B is going to have x and x minus 1 squared, right? Because when I multiply all four of these by x squared and x minus 1 squared, here only one of the x's is going to cancel out. C has x squared, and D has the same problem that B has. It has both of the factors, right? Because neither one of them fully cancel out. Now, I know that that means if I only have two convenient values, I'm only going to be able to find two of these up here. So let's go ahead and find those. So let's let x equal to 0. And if we let x is equal to 0, we get 1, and that's a times negative 1 squared plus b times 0 times negative 1 squared, plus c times 0 squared, plus d times 0 squared times negative 1. Well, the only one that doesn't cancel out is the a. All three of these have 0 as factors. That negative 1 gets squared, so it turns into a positive 1. So I have a is equal to 1. Now, we're going to go ahead and let x equal to 1 now as our other convenient value by the Heaviside method. And that is going to be, if we let x is equal to 1, we're going to get 7 over here. All the rest of these are going to cancel, but let's go ahead and show it since we're just kind of, a is equal to 0 squared plus b has 1 times 0 squared, and c has 1 squared, and d has 1 squared and 0. So all three of these cancel out, and basically I'm left with c is equal to 7. Okay, well, that may not be the most fun thing in the world, but we can go ahead and take a and c and plug them back in. We haven't gotten fully to where we want to be, but we're close. Now, we have 1 for a, and that winds up being x minus 1 squared, plus b, x minus 1 squared, plus c, but c was 7, x squared, plus d, x squared, x minus 1. Now, we have two of them. We still are looking for b and d. Now, what I did in the last one is I multiplied all these out and rearranged them so that I could compare the coefficients, okay? And I could do that. I mean, I'm missing a cubic and a linear term, but I can just do 0x cubed plus 6x squared plus 0x plus 1 because those coefficients are there. They're just not stated explicitly because they don't need to be. But what I'm going to do instead is I'm going to plug in other values. And what happens, let's go ahead and let x is equal to 2. Now remember, this is true for all x. So even though these aren't convenient values, they're perfectly legitimate for me to plug in. And when I plug in 2, I'm going to get 25. Okay? And when I plug in 2 right here, I'm going to get a is already, we're going to plug in here. That's going to be 2 minus 1, or 1 squared. B is going to be 2 minus 1 squared. 7 times 2 squared plus d times 4, which of course 2 squared, and times 1. Okay. Well, let's go ahead and clean this up a little bit. That's 25 is equal to, that's 1 and 28, so that's 29, plus 2b plus 4d. Okay, well that means I have 2b plus 4d is equal to negative 4. Did I mess up somewhere? I don't think I did. Okay. So what I have here is I have, no. So this is positive 4 because I basically, No. That's right. It's negative 4. So what I have here is I have b plus 2d is equal to negative 2. Okay, well, that's interesting. What I'm going to do is I'm going to do the same thing for x is equal to negative 1. Okay, so let's go ahead and rewrite our equation so we don't have to make recourse back to the previous page. And we have x minus 1 squared plus bx minus 1 squared plus 7x squared plus dx squared x minus 1. Okay, so what I'm going to do is I'm going to let x is equal to negative 1. Okay, well, if x is equal to negative 1, I'm going to get 7 over here, right? That's going to become negative 2 squared. That's still 4. That's going to be b times negative 1. That's going to still be 4. And we're going to have negative 1 squared here, so that's going to be 7. And then we're going to have d times negative 1 squared, which is just 1, and then this is going to be negative 2. Okay, well, this and this can be subtracted from both sides, so that's easy enough. And I'm going to get 0 is equal to 4 minus 4b minus 2d. Okay? Now, what we need to do here is we need to go ahead and just sort of clean this up. This winds up being 4b plus 2d is equal to 4. So 2b plus d is equal to 2. Okay? Oh my gosh, I have one equation. From the previous page, I have another equation. Wow, I can actually use systems here. Isn't that dandy? So let's go ahead and line these up as a system of equations. Let's go ahead and multiply this first one through by a negative 2. So negative 2b minus 4d is equal to 4. Sorry, I shouldn't have put that line there. Plus d is equal to 2. So I'm going to add straight down, and I'm going to get negative 3d is equal to 6, or d is equal to negative 2. And once I have d is equal to negative 2, I can plug back into any one of those. Okay, I'm going to plug back into the first one, or a form of the first one. So b is equal to negative 2 minus 2 negative 2. So that's a negative 2 plus 4, or just 2. So from the previous page, remember, a was equal to 1. Now I have b is equal to 2. From the previous page, I had c is equal to 7. And now I have d is equal to negative 2. And that means that 6x squared plus 1 over x squared, x minus 1 squared, is 1 over x squared plus 2 over x plus 7 over x minus 1 squared plus negative 2 over x minus 1. And unless I made an arithmetic mistake somewhere in there, which I don't think I have, that is my decomposition. And of course I can check my answer by sort of recombining it, getting a common denominator and recombining all of it, simplifying the numerator and seeing whether it actually simplifies out to 6x squared plus 1. That was kind of a long one. Let's go ahead and flip on to the next one. This, I think, one's going to be a little more straightforward. I don't particularly like doing it by systems. Sometimes you kind of have to. I like doing it by coefficient comparison. And you would have gotten in this one roughly I mean, you pretty much would have gotten a system by coefficient comparison. And so I like doing it that way. But I want to show you all the different ways and allow you to decide what method you feel is best. Okay? So let's go ahead. This one obviously is a quartic, but the quartic is quasi-quadratic, right? It has a quadratic form to it. So x squared winds up being, let's actually do the initial factoring and then we'll do the full, final factoring down here. That's x squared minus 4 and x squared plus 2. So that means we have x plus 2, x minus 2, and x squared plus 2. No, this one has a new element as well. I now am faced with a factor in the denominator that is an irreducible quadratic. Okay? My x squared minus 4 was reducible. It was factorable. It pulled apart into two other fractions. This is an irreducible quadratic, and therefore it has to be dealt with differently. Now, an irreducible quadratic in its lowest form, as a fraction that is not improper, not a top-heavy fraction, can have either a constant or a linear. Okay? And so we have to afford for both possibilities. So when we pull it apart, we have to, over the x squared plus 2, we have to put cx plus d. Now, it could be that it's just a constant over the x squared plus 2. There could actually not be a linear over it. Well, if that's the case, the algebra will bear it out, and you'll wind up getting a c value that's equal to 0, okay? But let's go ahead and, just like always, go ahead and multiply through in order to get rid of the rational structure. And I just went ahead and multiplied those together. Now, I have two convenient values. Let's go ahead and explore those. So let's let x equal to 2. Now, when x is equal to 2, and I'm not going to deal with the terms anymore that wind up being 0. When I plug in 2, this term is going to be 0 because it's going to be 4 minus 4 right here. This term is going to be 0 because it's going to be 2 minus 2. So the only one that's going to be left is this one right here. Okay, so when I plug in 2 here, I'm going to get 4. When I plug in 2 here, I'm going to get b times 4 times 6. And therefore, b is equal to 1/6. Okay, well, let's go ahead and let x equal to -2. That's our other convenient value, right? Well, that's still 4 on the left-hand side. That's going to cancel out both of these terms, and it's only going to leave the a. And so what I have is a times -4 times 6, and therefore a is equal to -1/6. Okay, well, that's kind of nice and tidy and stuff like that. So what I want to do from here is, let's go ahead and do the coefficient comparison. But I can go ahead and plug in my a and my b, right? So if I have x squared is equal to -1/6 x minus 2 x squared plus 2, and +1/6 x plus 2 and x squared plus 2, and then cx plus d times x squared minus 4, I have fractions. Oh, and the thing is that, should you be able to work with fractions? Sure, but if you don't have to, why would you want to? The easiest thing to do in this case is just multiply through by 6, and we'll do that as we're sort of simplifying these. Let's go ahead and multiply these as well. So we're going to get first, right? And let's do it in descending order. So inner, and then outer, and then last. Multiplying by 6 also gets rid of that one right there, and I'm going to get x cubed plus 2x squared plus 2x plus 4. So the terms here in both of these are relatively similar, just some plus and minus differences. Plus 6 cx cubed plus dx squared minus 4cx minus 4d. Now let's go ahead and expand all those out, and 2x squared minus 2x plus 4 plus x cubed plus 2x squared plus 2x plus 4 plus 6 6cx squared plus 6dx squared minus 24cx minus 24d. Now, a couple of these go bye-bye. This and this are additive inverses. This and this are additive inverses. And now I want to collect like terms. Well, in collecting like terms, let's go ahead and this is second degree, this is second degree, this is second degree, and actually this is supposed to be third degree. This is second degree, this is first degree. So I have 6c x cubed, that's the only cubic. Now, among the quadratics, the second degree terms, I have 2, 2, and 6d. Okay, so that winds up being 6d plus 4x squared. The linears, I only have one, right? Because the linear right here, the linear is simply right here. All the other linears here and here basically wound up going bye-bye. 24cx. And then my constants, I have 8 and minus 24d, plus 8 minus 24d. Now, in order to compare the coefficients, I need to actually have all of those coefficients represented. And you'll see now that this winds up being kind of neat. 6d plus 4 minus 24cx plus. Now remember, the whole justification for doing this is the fact that because this is true for all x, it's basically this has to be equal to that. And if this is equal to that, then its corresponding coefficients have to be equal as well. And that means that 6c is equal to 0, and therefore c is equal to 0. Well, that was kind of neat. Okay, well, let's do this one as well. So 0 is equal to 8 minus 24d. That means 24d is equal to 8, or d is equal to 1/3. Now remember up here when I said if it doesn't happen to be a linear, then the algebra will bear it out and give you a c value of 0. Ta-da! Okay, I don't have enough room to do it on this sheet of paper, so I'm going to kind of bleed over into the next sheet of paper. Now remember, I had a is negative 1/6, b is 1/6. So I have a over x plus 2, b over x minus 2, and cx plus d over x squared plus 2. That means that I have negative 1/6 over x plus 2, and b, of course, was positive 1/6 over x minus 2, and then c was 0, and then I had 1/3 over x squared plus 2. Well, I don't like the fractions within a fraction, so what I'm going to do is I'm going to factor out a 1/6 and just leave negative 1 over x plus 2, positive 1 over x minus 2, and 2 over x squared plus 2, and that is my decomposition. Okay. And so that of course is our first example of using an irreducible quadratic. Let's go ahead and do another example using an irreducible quadratic. Now in the past we had a problem that was x cubed minus x, and that of course gave us 3 linears. This is x cubed plus x. This gives me, of course, the GCF linear of x, but also gives me x squared plus 1. Now, thankfully, this doesn't have as many factors as the last one, so it's actually going to be much quicker, right? And so we get x plus 1 over x squared plus 1, and this is going to be a over x and bx plus c over our irreducible quadratic. Now, let's go ahead and multiply both sides by the common denominator. Oh, whoops. And I get bx plus c times x. Now, I could go ahead and use x is equal to 0 for my convenient value, but since we've done coefficient comparison in the past and it's been kind of neat and this is a relatively easy problem, let's go ahead and do that. And we notice that we're going to get a plus b for x squared, c for our linear coefficient, and a for our constant. So if we have 0x squared plus 1x plus 1 on the left side, then obviously a is equal to 1. Also, c is equal to 1. And if I take the quadratic coefficients, I notice that a plus b is equal to 0, which means b is equal to negative a, so b is equal to negative 1, and it really does go boom, boom, boom that quickly. And so what I have here is I have 1 over x plus negative x plus 1 over x squared plus 1. And that is my decomposition. And if you're curious, is that really? Well, okay, let's go ahead and check the answer. This one's pretty easy to check, as it was pretty easy to do. We need to multiply this one by x over x. Okay, multiply this one by x squared plus 1 over x squared plus 1. That's going to give me x squared plus 1 minus x squared plus x. All of that over x times x squared plus 1. Oh my gosh, those cancel out, and I get x plus 1 over x cubed plus x, and it checks out. Fabulous. Okay. We're going to go ahead and call this one to a close as well. Going to have one more video where we discuss just a few more examples. There's one last thing that we really do need to discuss. And then we'll be done, and we will, of course, on Monday start dealing with these as strategies for changing an integrand and then going ahead and doing the integration. If you have any questions, as always, please do shoot me an email. Bye.